going to talk about solving quadratic equations by graphing. And so first of all, let's define what a quadratic equation actually is. A quadratic equation is an equation that involves a quadratic function. Okay, so remember we talked about quadratics on Friday, and quadratics had a power of what? What was the highest power in a quadratic? 2. Okay, and so the standard form of a quadratic equation, ax squared plus bx plus c equals 0. Now notice here a cannot equal 0, because if it did, you wouldn't have an x squared term. Okay, a, b, and c are all integers. Integers meaning no what?
Fractions.
No fractions. Okay, so a, b, and c can't be fractions if it's in standard form. So now what we're going to do is we're going to talk a little bit about the graphs. And then we're going to get into actually graphing a quadratic. And so first of all, we have what are known as the roots. The roots are the solutions of the quadratic equation. The zeros. So if I ask you to find the zeros, I'm asking you to find the x-intercepts. The key part here is that we need to let y equal 0. Remember, to find the x-intercepts, we always let y equal 0. And so down below is actually an excerpt from your book. And so this talks about a graph of a quadratic function. And so if you look at this, the quadratic function is f of x equals x squared minus x minus 6. Okay, and so if I were wanting to find the x-intercepts or the zeros, what I would do is I could go ahead and graph that, and notice that I have one x-intercept at -2, one x-intercept at 3. So therefore, we would say that the x-intercepts are -2 and 3. Also, we would say that -2 and 3 are zeros of the function. And we could also say that -2 and 3 are roots of the function. So let's think about that. X-intercepts, zeros, and roots are all synonymous. What does that mean? They're all the same, right? So if I ask you to find the roots, that's the same thing as finding the zeros. If I ask you to find the zeros, that's the same thing as finding the x-intercepts. So basically, if I ask you to either find the zeros, roots, or x-intercepts, you're going to do the same thing. Okay. All right, so now, what we're going to do is we're going to solve the following equations by graphing. So what I need you to do, first of all, write this down so that you know what function we're dealing with. X squared minus 3x minus 4 equals 0. And so then what I want you to do is I want you to go to that website, rentcalculators.org. Now we're not going to rent a calculator, okay, but this is a website that has an online graphing calculator that's for free. So I tried to find a website that was easy to remember. So I need you to go ahead and type in rentcalculators.org. Okay, rentcalculators.org. Now when you do that, what's going to happen is it's going to take you to this site right here. It's going to take you to that site right here. Where you need to go is you need to go over here to free online calculator and go ahead and click. Now what's going to happen is it's going to bring you to this screen right here. You need to go to this one, free online graphing calculator. Now what's going to happen is this is going to open in a separate window. And so if you notice, this is what I'm going to get. Now what I need to do is, notice I've got the ability here to graph 4 values of y. y1, y2, y3, and y4. So I'm going to come up here to y1, located right by the red. I'm going to type in x squared. So how you type in the squared is you use the caret key, which is located right by the number 6. So x caret 2 minus 3x minus 4. Okay. Now in the second one, what I'm going to go ahead and put is I'm going to go ahead and put 0. Now the reason why I'm doing 0 is because that's what I want the function to equal. Okay, now you're going to notice there's a graph button over here in orange. I need you to click graph. Okay, it's located right below the plus sign. Click graph. There is the graph of the function. Now if I want to find the zeros, the roots, or the x-intercepts, I can see where they're at. Now say for example it wasn't easy to see. I'm going to go up here to intersection. You see that at the very top? You have equations, settings, intersection, plot points. If I click intersection, notice what I've got. I've got the two functions. Okay, what I need to do there is select the 2 points. Notice how I'm doing that. I'm going over to the left to the white box. And then what do you think I'm going to click? Find intersection points. There you go. There are your 2 solutions. So your zeros, your x-intercepts, and your roots are all -1 and 4. So that's how you would solve that one. Okay?
So -1 and 4 is the answers, or
-1 and 4 are your answers. And that's it.
because it's just the x.
That's just the x-intercepts, exactly right. Now the nice thing about this is eventually we're going to be able to figure out what is the value of this vertex point down here. Okay, which is going to be really neat and all of that stuff. But for today, all we're doing is intersection points. So let's go back and see our next problem. Okay, so we know that our equation is going to be -1 and 4. There you go. That's all you need to do. So with that in mind, x squared minus 8x equals -12. Now this one's different because it's not in standard form. So what do you think you need to do first?
Plus 12.
Add 12, yeah. So I need to put this in standard form. So then now what I'm going to do is I'm going to be left with x squared minus 8x plus 12 equals 0. Go back into your graphing program. All you need to change is the top equation. So change it so that it's x squared minus 8x plus 12. Go through the steps and tell me what your solutions are. You forgot your square. You forgot your 2 right there. So x squared 2. Okay, so what did we get our answers to be? 2 and 6. Nice job. 2 and 6. Okay, so now real quick we got one other thing we need to talk about, and that's what is you see is the following. This is another excerpt from your book. It says a quadratic equation can have 1 real solution, 2 real solutions, or no real solutions. And so if you notice where the parabolas are located, indicates whether you're going to have 1, 2, or no. So the past 2 problems, what did we have? We had 2, because the parabola was located below the x-axis and it went up. Now notice I could also have 2 solutions if the parabola was like this. So they can't open down. Okay, likewise, I can have 1 real solution if the parabola opens down and the high point is here. And I can have no real solutions if the parabola is open down here. And so basically, however many intersection points you get, that will tell you whether you have 1, 2, or no real solutions.
So no real solution has an intersection point on the x-axis.
It won't. The no real solution will have no intersection points, okay, because it never
So that
touches
shouldn't-
the
that
x-axis.
shouldn't be intersecting.
No, intersects the x, this one, not the y,
Um,
okay, just this one, just the horizontal one. So let's go ahead and look at a few more examples. Now if you look at this one, this is a little different, because notice how it is written. So what I need to do is I need to go ahead and rewrite this so it's in standard form. Now I can move everything over to the left side and have a negative x squared. I don't like to do that because I don't like my x squareds to be negative. So what I'm going to go ahead and do is I'm going to go ahead and add x squared to both sides. and then I'm also going to subtract 14. So I end up getting on the left 0 equals x squared minus 6x
plus
9. Okay, go ahead and graph it. Tell me what your solutions are. So go ahead and graph x squared minus 6x plus 9.
3.
What do you notice? It just sits on the x-axis. It has one x-intercept, and that intercept is at 3. So that's an example of where you would get 1. So let's look at another one. X squared plus 5 equals negative 8x minus 11. Did you not get it?
Well, no, I
Oh.
just was confused because the 0 was on that side.
Oh,
So that
okay.
doesn't make a
No,
difference.
nope, it doesn't. So now, biggest thing is we need to solve that. So let's go ahead and add 8x to both sides, and let's go ahead and add 11 to both sides. So you end up getting x squared plus 8x plus 16 equals 0. So x squared plus 8x plus 16 equals 0. How many solutions? None, 1, or 2? 1. We're at -4. Okay, questions? Isn't technology great?
Yes.
I mean, can you imagine if you had to graph these by hand? So, let's go ahead and, oops, just a second. Let's go back to there. Solve by graphing. If exact roots cannot be found, state the consecutive integers between which the roots are located. So basically, they're telling you it's not going to be a whole number. Like the ones that we did before, it's not going to be a whole number. So I need you to go ahead and graph x squared minus 6x plus 4. And I'm going to go ahead and graph that up on the board as well so that we can kind of see. So x squared minus 6x plus 4 equals 0.
0.7.
Okay, let's see what we got here. So x squared minus 6x plus 4. And you're going to get something that looks like that. And so as you see, it's not a specific value. So I'm going to go up here to intersection. And when you find the intersection points, oops, forgot to select 2 equations. When you find the intersection points, that's what you get. Now, if you remember what the question was find the 2 consecutive integers it goes between. So really, I wouldn't need to find the intersection points because I could look here. This first 0. So let's go ahead and, okay, this first 0 occurs between this point and this point, which is what? Between 0 and 1. So that would be your first answer, 0 and 1. Your next point is going to be between this point and this point, which is between 5 and 6. So your answers are going to be between 0 and 1, that's your first one, and then between, what was our next one, do you remember? 5 and 6. And so that's your answer. That's all you need to do. So today your assignment is going to have to be using the netbooks. And so what you need to do is use the remaining time, get it done. You should be able to get this done before the end of the period. It's on pages 233 through 234, 14 through 29. You need to solve them exactly as we did in class. Solve them exactly as we did in class. Now the first few aren't ones that you're going to need to graph. Okay, you can just go ahead and I would probably start at 20, do 20 through 29, and then go back and do 14 through 19, because 14 through 19 can be done at a later time. And that is due tomorrow.